So now we will start with the network theorems. First we'll discuss the superposition theorem, which is the simplest of the network theorems. And to understand the superposition theorem, we first have to understand this statement. This point number 1. The current through or voltage across any element of a network is equal to the algebraic sum of the currents or voltages produced independently by each source. Now what does that exactly mean? First let's draw a circuit or a network with two sources. It can be multiple sources, many more. Just for simplification, I'm saying two sources. Okay. So here we have two sources. Now what this statement is saying is that if the current produced by this voltage source is, let's say, I1, and the current independently, okay, the current produced by this voltage source independently is I1, and the current produced by this current source independently is I2, then the total current that will flow through this load, which will be IT, can be calculated as IT is equal to I1 plus I2. So basically, if we can find the current produced by each source independently, then we can add them up to find the total current flowing in the circuit, okay, or through any component of the circuit. Now to do this, we obviously have to isolate each source and analyze them separately and find the current produced by them independently. So for this, we have to replace every other source that we are not analyzing for now. So if we are analyzing the voltage source, then we have to remove the current source. And if we do that, removing the current source means we replace it with a short circuit. An open circuit, which means two disconnected terminals. And if we are analyzing the current source, then we have to remove the voltage source or any other source that we have. And if we're removing a voltage source, we will replace it with a short circuit, a straight line. So these are the base rules. Now let's do some practice questions to understand the things better, understand the theorem better. So here we have a network with two sources, voltage source and current source, where the voltage source is E 36 volts and the current source I 9 amperes. First let's analyze the voltage source. And our question is, we have to find the current flowing through this resistor R2. IR2 is equal to what? So for ease of explanation, let's redraw the circuit, but eventually we'll have to learn to do it without redrawing, do it in our mind with some imagination power. It'll save us time. But now let's redraw the circuit. We will remove the current source because we want to analyze the voltage source. So removing the current source means we will replace it with an open circuit, two disconnected terminals here. Now what a short circuit means, that there is no current flow beyond this point. Okay, these lines are just for sure there's no current flow. This is essentially a series circuit here. The current will flow in a linear direction like this, without any branching out. So that means the total, the equivalent resistance here will be RT is equal to R1. RT is equal to R1 plus R2. So 12 plus 6 equal to 18 ohm. That's our equivalent resistance. And so the current produced by the 36 volt will be I is equal to, let's say it's I1. I1 is equal to E over RT. So 36 over 18 is equal to 2 ampere. That is the current produced by the voltage source 36 volts. And since this is a series circuit, so 2 ampere will be flowing through the resistor R2. Now we have to find the current flowing through resistor R2 due to the effect of this current source 9 ampere. Let's do that here. Again, let's redraw the circuit for ease of explanation. So now we will replace the voltage source with a short circuit, and the resistors will remain as they were. And here the current source. Okay. Now notice that these two resistors are parallel to each other. They have two common points. Okay. So this is a parallel circuit, which means that the current flowing through R2 6 ohm and R1 12 ohm will be different. And to find the current flowing through R2, we will have to employ the current divider rule. Now in this type of scenario where there's only two resistors in parallel to each other, we can use a shortcut of the current divider rule, which will be I2, let's say it's I2, is equal to, for the shortcut, first we put the resistor which we want to calculate the current flow of, which will be R2 in our case, in the denominator, and then we add the other resistor, so R1, and then we again put that other resistor on the top in numerator, and then we multiply it by the total current I. Now let's substitute the values. So R1 is 12 ohm, that's not right ohm here, 12 over R2 is 6 plus again 12 times total current I, which is 9 amperes, 9 ampere, so times 9. Now let's put that in the calculator. 12 over 6 plus 12 times 9, so we have 6 amperes. I2 is equal to 6 ampere. So that means due to this current source 9 ampere, we will have a 6 ampere current flow through the resistor R2. Now we have I1 and I2, the two currents flowing due to the two independent sources. Now to find the total current flowing through 6 ampere, we have to just add them up according to the superposition theorem. So let's say IR2 is equal to I1 plus I2. What was I1? I1 was 18 ohms. Wait, no, sorry, I1 was 2 amperes. So 2 ampere plus I2 is 6 ampere is equal to 8 amperes. That is the total current flowing through the resistor R2. Now let's do another question. Now our task here is to find the current flowing through the resistor R2. So IR2 is equal to what? Again R2. Now we'll employ the same techniques. First, let's redraw the circuit with the resistor by removing the resistor, removing the source E2. So we will analyze for E1 first. An open circuit, sorry, a short circuit, and then we are analyzing for E1. So E1 will stay as it is, and the resistors will remain as they were, and then we'll replace E2 with a short circuit. Now we can see that R2 and R3 are parallel to each other with two common points, but R1 is in series with the rest of them. So let's find the total equivalent resistance. RT is equal to R1 plus R2 parallel R3. Now let's place the values. So R1 is 24 plus R2 is this parallel sign basically means we are just doing this. So 1 over R2, which will be 12, plus 1 over R3, which will be 4, and to the power minus 1. This parallel sign basically means this. Let's put that in the calculator. So 24 plus 1 over 12 plus 1 over 4 to the power minus 1. So we have 27 ohms. That's RT. Now what will I1 be? I1 is the current flowing due to the voltage source E1. So I1 is equal to E1 over RT. So 54 volts over 27 ohms. So that is 2 amperes. That is I1. So that is the current produced by the voltage source E1. And now we have to, since this was a parallel circuit, this entire 2 ampere is not flowing through R2. We have to now employ the current divider rule again to find the current flowing through R2. Now again we can use the shortcut of the current divider rule. So let's say it will be I1 prime. Okay, sorry, not double prime, just prime. I1 prime is the current flowing through the resistor R2 due to E1. So I1 prime is equal to, again, the resistor we need, so R2 plus the other one R3, and then on top the other one, times the total current, which is I1. Okay, let's copy this and go to the next page. It won't copy. Okay, let's just do it here. So I1 prime is equal to R3 is 4 ohms. So 4 over R2 is 12 ohms plus R3 again is 4 ohms times I1. So that's 2 amperes. Let's put that in the calculator. 4 over 12 plus 4 times 2. So we have 0.5 amperes. So 0.5 amperes are flowing through R2 due to E1. Let's just mark this in red so that we can find it quickly later. Now we have to find the current flowing through R2 due to E2. Again, let's redraw for ease of explanation. Now we'll replace E1 with with a short circuit, and then the resistors as they were. Okay, now it's again a parallel circuit, but now R2 and R1 are in parallel and R3 is in series with them. So let's find the total equivalent resistance again. So this time it will be R3 plus R1 parallel R2. So 4 plus 1 over R1, so 24 plus 1 over 12 to the power minus 1. So that equals to 4 plus over 24 plus 1 over 12 to the power minus 1. So we have 12 ohms. Equivalent resistance is 12 ohms. Now let's find the current. So I2 is equal to E2 over RT, so 48 volts over 12, which is 4 amperes. Now again, this is a parallel circuit, so 4 amperes are not flowing through R2. It's the total current. Now we have to again do the voltage, current divider. We can use a shortcut again for finding the current flowing through R2 due to E2. So I2 prime is equal to, this will be I2 prime, okay, equal to, again, so the resistor we need, R2, plus the other one, R1, on top the other one, and times the total current, so I2. Now let's put the values. So R1 is 24 over 12 plus 24 times 4 amperes, and that equals to 24 over 12 plus 24 times 4. That's 2.67 amperes. 2.67 amperes. Okay. Now to find the total current flowing through R2, let's do it here. IR2 is equal to I1 prime plus I2 prime. That's the superposition theorem. 2 prime. So what was I1 prime here? We highlighted in red. So 0.5 amperes. 0.5 amperes plus I2 prime. Now before we place the value of I2 prime, we have to remember that we have to note the direction of the currents from the two sources. See, E1 is having its current flow this way. E2 is upside down. Plus is down here. So the current is flowing this way. Okay. So for the I2 prime will actually be up here. It's not like this. It will be like this. So this is I2 prime. And I1 prime was going down here. I1 prime. So they're in opposite directions. So here we have to put one of them as a negative value. So let's say 0.5 plus I2 prime, this we'll consider to be negative. So minus 2.67. So that means 0.5 minus 2.67. We'll have a value now. 0.5 minus 2.67 minus 2.17. Actually, we have to consider the larger. We can just write it here, minus 2.67, I mean 2.17. But we will not use this minus value. We'll actually use it as 2.17. Now to avoid confusion, what we can do is get rid of all of this. Where's the eraser? So get rid of this and this and this. We can consider at the beginning of the calculation, we can just put the larger value to be positive. So here we can see 2.67 is obviously larger than 0.5. So we will just do I2 prime minus I1 prime. So 2.67 minus 0.5. We'll consider the smaller value to be negative, so that finally we get a positive value. So 2.17 ampere. We get a positive answer. So that's the current flowing through R2, or 12 ohm here. Now I have some more practice questions for you, but I'll let you do that yourself. It's all the same steps. Just follow the steps from here. It's all the same steps. They're all simple. Pause the video and try to solve them yourself. It will be very good practice for your exam, and these are the type of questions that will come in the exam. and if you need the solutions to them, please let me know in the comment section.